22 kilogram box is on a surface, I meant horizontal surface, which is what we're dealing with. All right, and right away we can freeze frame this and draw a picture. 22, surface. The mu-s and the mu-k are given to us. So our mu-s, our coefficient of static friction, is 0.37, and our mu-k is equal to 0.11. All right. The force applied to the left is now 318.44. And the force to the right is 212.67. Tell me, which direction does the box move? Which value is larger than the other? Good. The box is moving to the left now. The force is coming and pushing that way. It's going to the left. So, without even doing any work, we know that A is to the left. Now, it's asking us how far will it move in 3.88 seconds. But wait, we have to calculate these friction forces first. So, again, tell me, how do we find the static friction force? That's right. We do the coefficient multiplied by the normal force. And the same goes for the kinetic force. 0.11 times Fn. What is the equation for the normal force? You're right, it is mg. So I'm going to go ahead and just write that right now. 22 times 9.8. Our mass, 22 kilogram box, times gravity. That gives us 215.6 newtons. Let's find our static and kinetic force. Our static force is equal to 79.77 newtons. And our kinetic force is equal to hang on a second, type that in wrong. 23.72 newtons. So here we have two different frictional forces. Okay, good. So we don't even need to worry about letter A anymore. Let's just focus here. How far will it move in 3.88 seconds? Let's first figure out if the total force or the net force applied on the box is larger than our static force right here. So if we're going to do the net force, we're going to do 318.44 minus 212.76. So let's do that. 318.44 minus 212.67. That gives us a net force applied on the box of 105.77 newtons. This net force is larger than our static frictional force, meaning we don't have to worry about the static frictional force anymore. We can actually just worry about and focus on the kinetic frictional force. So if a net force of that is applied onto the box, what's the net force that the box is feeling? Well, we're going to subtract our kinetic frictional force from this net force applied. So let's do that. That leaves us with an F net, or the total force that that box is feeling, of 82.05 newtons. 82.05 newtons. Now, we just do what we did in the last problem. I'm going to erase some of this so we have more room. We say, okay, F is equal to MA, and XF is equal to 1/2 AT squared. Let's find A. 82.05 is equal to 22 times A. Our A is equal to 22 over, 82.05 over 22, which is equal to 3.73 meters per second squared. Okay, good. Now, let's plug in everything we know for our XF. Say our XF is equal to 1/2 our A that we just discovered right here, 3.73, and the time, which is given to us in the question, 3.88 squared. And let's just do that. So 3.73 times 0.5 equals times 3.88 squared. That leaves us with a total distance for that box traveled in that time, 28.1 meters.